Now
Yes, I can see that.
all can see. Okay, let's start. So the question was, what will happen if I call f truncate after I call m map? So let's see whether and we have came to a conclusion, right? We can call f truncate anytime. So initially we are setting the size to 4096, and then we are calling f truncate to 204. So you can see the size previously was 4096, and now it became 2048. So using f truncate, anytime you can reduce the size of your shared memory set. So whatever you are changing the calling after you call mmap, you perform read and write. Will this be visible to other processes before calling mmap? Let's try. So this is the old producer code. So I have added a user input before calling mmap. So this is the same code where we are creating a shared memory segment and we are writing some messages. Message 0, message 1, and message 2. And I'm just, before actually performing m and map, I'm waiting for user input. And the consumer code is the same code. So it just opens the shared memory segment in read-only mode, then performs mmap, then it tries to read from the shared memory segment. So there is no need of calling f truncate because the size is already set. So I run the producer code. Its writing is complete, or it is saying try consumer now. So I run the consumer code. So I get whatever is being written. So it's not so important to have like, it's not like M and map will actually write to the shared memory segment. It depends on the kernel. Kernel can perform timing operation, and at any time it can write whatever you are writing into the process. It's the same code. The same code. So we have seen this example when we are doing fork. So this is the same code. In the fork, we have tried modified map shared, and we have seen with map private. This is not important. So any doubts in the shared memory? We have completed shared memory. So what is a major problem with shared memory? There is no synchronization here. So what if multiple processes have mapped to the same shared memory segment, and they're trying to perform read and write operations? So there is no blocking call here. So there is no synchronization here. You have to manually perform synchronization using semaphores. So we'll see semaphores tomorrow. Today we'll be just completing memory maps. So we'll see into file memory maps. So we will see memory map IO will perform us, allow us to map a file which is present on the hard disk or any storage media into a buffer in memory. So memory mapped IO will allow us to map a file which is present on a storage media, SSD, hard disk, anything, into a buffer, so we can fetch the bytes from the buffer, and whatever the bytes of the file are read, we can store the data in the buffer. When we store the data in the buffer, the bytes are automatically written into the file. So using memory map, we can perform normal read and write operations, and file data is being read and file data is being written. No need of calling the read system call or write system call. So we have already used mmap and munmap, right? Using it needs a file descriptor. So what happens if I give an after I call open, I have a file descriptor, I will give this to mmap. So using then there is no need of calling read and write. So I can just use normal address operations, scanf and printf. So how does the operating system load my processes? We have seen, right? It uses mmap system call. What are the advantages of mmap over normal file access function, right? Read and write. So using memory map files, multiple processes share read-only access to a common file. So for example is the C library. C library, which is glibc.so, is mapped into all the processes which is running C programs. So there is only one copy of the file present in the physical memory, even there if there are thousands of programs running. So this mapping is used, mmap is used here to map C standard library. So if you are performing random file location using fseek, it will be taking time if you are using fseek and read and write. But if you are having an array, you get an array and you perform mmap, it is a faster mechanism. So when you call read, right, to access a file, the contents are first copied from disk into the kernel buffer. Then that data is copied into the process user mode memory. So there are two operations. When you call read on a file, the contents of the file are copied into the kernel buffer. In the kernel buffer, data is copied into the user mode memory. What are the memory you have given in read? But in case of memory map, there is no buffer cache here. So whenever your data is directly copied into the user portion of memory. So one step is reduced in case of memory map. In case of normal read and write, there is two steps. First, data is copied into the kernel buffer. From the kernel buffer, it is copied into the user mode. So these are the advantages of memory map files. How can I use memory map? So suppose I have a file hello.txt. Okay, I'm just deleting it. Suppose I say echo hello world. I create a file hello.txt. Have hello world present in the file. So if I want to perform a memory map of this file, I can open the file hello.txt in read-only mode. Okay, and then I'm just calling mmap. So there is no f truncate because we are not dealing with shared memory segments. Mmap, I'm passing null. As I know, I want to only read 5 bytes. So I say length of 5 bytes. I say protection is read, shared between processes. The file descriptor given by FD. Offset is 0. So I get the address here. Then I can normally access the address as an array. So I'm accessing the first location, second location. So I'm having a char pointer, so I'm using %c. So I'm just printing those. So you can see I'm not calling read or write system calls to read the file contents. So we are directly accessing the from the pointers. As we have mapped the file contents, the our own address space. Finally, I'm calling munmap. You can see I have read successfully 5 bytes of the file without calling read and write system calls using mmap. In this case, I'm opening the file in read and write mode. I'm setting the protection to write protection, sharing the file between processes. Now, instead of In the previous example, we are reading the content, but here I am writing the content. So I'm updating the first byte to B, second byte to Y, third byte to E, and then I'm performing M unmap. Now before this, the content of the file is hello world. When I run this code, the content will be HEL is being updated and we have BY. Any questions? So how can I get the size of the file? You can see we are manually passing the size here. So if I want to get the size of the file, what are the options we have? What are the options if, if I want to get the size of the file from my C code? Can anyone guess?
size
So if I perform lseek on the file descriptor and I say seek end, what lseek will give me? What is the return value of lseek?
End of the text.
Yes, it will give me the new file descriptor offset. Upon successful completion, lseek will return the resulting offset location as measured in bytes from the beginning of the file. So we are setting the file descriptor offset to the end of the file. So the new location will be end of the file, which is nothing. So the size of the file. So this is the content of the file. I'm printing whatever using mmap. So there is one more mechanism where we can get the size of the file. We have used when we are doing file operations. Where is the size of the file stored? Which data structure in which the size of the file is stored?
double link, circular double link.
No, what is the data structure? We know we have file content and metadata of a file stored separately. We call it something, right? We have permissions, we have timestamp. Is stored in which data structure? We have a name of the structure, right? inode. So when you all the metadata is stored in the files inode, right? So inode will also have the size of the file. Right? Stat is a system call which we can use to get the size of the file. So I can say stat and I can get the size of the file. So these are the two ways by which you can get the size of the file. One is using MC, the other is using fstat. So what happens when you do a fork? So as we are using map shade, whatever the operation performed by child, so we're just reading the data. So both will be reading the same data. There's no problem. So we are opening the hello.txt. We're mapping it to the address space. Child is reading the data and it is performing on map. So this is separate process. Parent is waiting for the child to terminate. It is also printing the address. It is also printing the data which is present on the address. That is performing a manual. So both are printing the same map. So what will happen if I try to access the data after M unmap? So I have unmapped the process. I have unmapped the file contents from the process address space. So memory map has been removed. Now I'm trying to write after I have performed M unmap. So it will result in segmentation fault because we don't have access to that particular segment. After removing the segment, we are trying to access that segment. Hence we get segmentation fault. So this is an example where we are opening a file in read-only mode. We are performing getting the stack, size of the file, and then we are memory mapping it. We are getting the address. Then we are calling the write. So we are just implementing a cat functionality here. So instead of calling read, we are calling write. So instead of calling read to read the file contents, we are using mmap to map the file into our address space, and then we are calling write. So we have to give the argument file name, and you can see it's simply working like a cat. So this example is used to copy, implementing copy operation using mmap. So we need two file descriptors. First file descriptor is source file, is open in read-only mode. The second file descriptor is the destination file which we are creating. We're setting the size to 0 using trunk. So we get the file descriptors. We get the size of the source file. We map it using mmap. The protection is read, and we are mapping it as a private. We get the address, starting address of the memory map, and then we set the size of the new file to size of the source file. So destination file is size is set, and then we are m mapping the destination address. So we now get the memory map of the destination address. Now we have the both addresses, and we are just calling main copy. So very simple way of implementing file copy operation. Instead of calling read write, we're just using mmap. So let's see how this works. So if I want to copy hello.txt into another file.txt. So this is permission denied. So let's see what's permission should be. So I'm just it's my mistake. I'm running dot slash dot c dot slash 8 hello.txt file.txt. So now we have performed copy operation. So the contents are seen. So using mmap, we have performed copy operation. So we have few words. There is something known as anonymous mapping. Instead of passing map underscore private, map underscore shade, you can pass map underscore anonymous. In case of anonymous, there is no file, and FD and offset arguments are ignored, and the contents are initialized to 0. So whatever the map, whatever size you are requesting for memory map, the contents are 0. So you can see I'm not opening any file, I'm directly calling a map. In place of FD, I'm giving -1, offset 0 is 0. I'm requesting a size of int. So as this is map shade and map anonymous, FD and argument is ignored. FD and offset argument are ignored. I'm getting a size of integer address. I'm incrementing it in the child process. I'm performing M unmap. In the parent process, I'm waiting for the child to terminate, and I'm printing the value. So whatever the parent child has increased, it should be present here. So child started with value 0 and it incremented the value, and parent is able to see it value 1. If you have map private, then this increment will not be visible in the parent process. And you can see the initial content is 0. With map anonymous, whatever the address space is given, the contents are initialized to 0. So what is the issue with memory map files? The issue with memory map file is timing of when updates get copied back into the file on disk. So you're writing actually to a memory map section. You're writing to the address space. You're not directly writing to the file. So kernel will perform the update operation. So it will see that memory map section has been updated, so it will write onto the file. So if another process opens and reads the file using read, will this other process see any updates which are happening to the memory map region? So the question is, there is another process who opens the file and is calling read on the file. And our process is performing memory map. We are accessing it using memory map. Will this new update will be seen by this file? This process, it depends on timing factors. So the first factor is kernel. Whenever a file is mapped into memory with mmap, kernel will occasionally trigger a write to copy the updated portions back to the disk. A second factor is file system. So in some file systems, only when you close the file, whatever you have updated in your memory map will be written to the file. So how many of you used sync sync function? Not sync function, there is a sync utility. So after you copy your data onto your pen drive, sometimes you may not be having the same data. Some data may be lost. So we normally use, after you perform DD, like DD operation to flash your pen drive, you call sync, so that whatever data you have written on the pen drive is being actually written perfectly. So similarly, we have something known as msync function. So this function will make sure whatever the data is present in the memory map is actually written to the file. So msync will synchronize a file with a memory map. Msync will flush the changes which are made to the copy of a file that was mapped into memory using mmap back to the file system. So without using this call, there is no guarantee that changes are written back before munmap is called. So it's saying that there is no guarantee when changes are being written back to the file before munmap is called. So you can see msync takes 3 arguments. The address and length are same as munmap, and flags. So you have 3 flags. So you can use a async, ms sync. So ms sync will wait until the update is completed, whereas async will schedule an update, but the function will return immediately. So this is a blocking function. It will block until your update is completed. This is a non-blocking function. We will just schedule a update. The function call will return immediately. There is invalidate. So if you don't want to update whatever is present in your memory map, you can say invalid. So you have to call msync. So you are making sure that whatever you are calling, whatever you are writing, is actually being written to the file. So msync is needed if you are performing write operations. When you are performing read operations, it is not needed. So we have not seen protection none. So what is protection none means you don't have any permissions. You don't have read permission, you don't have write permission, you don't have execute permission. So in case of protection none, if you're trying to perform accessing this any values, like you're trying to write, you give me a segmentation file. So I need to create a file. So it is opening hello.txt in the current. So I create a file. You can see segmentation flow because we have opened using protection none. So there's no protection. So there is one more system called known as mprotect. So mprotect will change the access protection for the calling process memory pages. So suppose you have opened memory map in none protection. Now you want to perform write operation. So you can change the protection using mprotect. You can now set the protection level here. Like initially I have opened in with protection none. Now I'm setting it to protection right. I can perform write operations. So it worked. The file got updated. So we have seen today memory map, shared memory and file memory map. You have any queries? Tomorrow we'll be looking into semaphores. How can I use synchronization between between processes using shared memory? Any queries?